Now let's talk about doing two vertical transformations in the same graph transformation problem. Then what? Basically, let the order of operations guide you. So if you know the graph of y equals f of x, in order to graph y equals c times f of x plus d, notice here the times first before the plus. So let's take care of the times. So in other words, first, vertically stretch by a factor of c. And then once you've done that, shift vertically by d units. Let's see an example of this, where we're going to have both a vertical stretch and a vertical shift. It is actually much easier to take care of the stretch first, and then to take care of the shift afterward. So, given the graph below, let's say this here is a graph of a function. This passes the vertical line test. It almost looks like it doesn't here, but it really does, because x coordinate 4 versus x coordinate 5. Okay, so take this graph. This could be the graph of a function down here, and then we're going to, based on this picture alone, graph y equals 2 times f of x plus 1. So we should take care of the 2 times first. So vertically stretched by a factor of 2. So you'll notice that each point that was in the picture up here has been redrawn in its new location, and you'll notice that only the y coordinates have changed. So this 4 multiplied by 2 and you have 8. This negative 6 here for the y coordinate, multiply 2 and you have negative 12. The x coordinate of negative 3 has remained. Okay, so do that for each of these points. So take a look. Negative 8, comma, positive 4 ended up at negative 8, comma, positive 8. Negative 3, comma, negative 6 ended up at negative 3, comma, negative 12. Positive 4, comma, negative 2 ended up at positive 4, comma, negative 4. 5, comma, 3 ends up at 5, comma, 6. So notice there's still a 5. Okay, 12, 2 ends up at 12, 4. Now that we have stretched vertically, this is really looks stretched too. If you really are unconvinced, go find a sheet of graph paper and graph very carefully, and you'll see that only affecting the y coordinate and not the x coordinate is really going to, it'll visually be much clearer that this is vertically stretched by a factor of 2. I think you can even see it here between the picture on the top in the question and this first picture in the answer. Now we have to take care of this plus 1. So take the most recent picture, and plus 1, the y coordinate grows by 1. In other words, you shift up by 1 unit. So every single one of the points here, we've just, because it's so hard to see in the picture, we've just actually labeled each of the points. So the y coordinate used to be 8, now the y coordinate is 9. Y coordinate used to be negative 12. Well, when you add 1 to negative 12, you get negative 11, and so on. So all these, and you can kind of almost see, if you look back and forth very carefully, that this graph in blue, it is shifted 1 higher. So the axes have remained in place, but the picture in blue has been raised up 1 unit. Again, just to comment on this, when applying the vertical stretch, you only change the vertical coordinate, the y coordinate that is. So 5, 3 became 5, 6, right? So 5, 3 went to 5, 6, not to 10, 6, which is usually the most common error.